In this video, we're going to continue looking at exponent rules. Previously, we looked at positive integer exponents, and now we're going to consider 0 and negative integer exponents. And we're going to do that by looking at this table. In this table, we see powers of 2 that decrease by 1 in the exponent as we go down each row. The next column asks you to write that out as a multiplication expression. In other words, 2 to the power of 4 means multiply 4 2's together. And then the last column asks you to simplify that. 2 to the power of 4 is equal to 16. Let's take a moment now and fill in the table down to 2 to the power of 1. If we do that, what we see is that as we go down one row, we are each time dividing by 2. 2 to the power of 3 means multiply 3 2's together, which gives us 8. Now, what happens when we get to 2 to the power of 0? Well, if we follow the same pattern, then 2 to the power of 0 must be equal to 1, because 2 divided by 2 is 1. And if we continue the pattern further, then 2 to the power of negative 1 must be 1 divided by 2, or a half. Continuing the pattern further, 2 to the power of negative 2 would put another 2 in the denominator and would equal 1 over 4. So let's complete the rest of the table using that pattern. So that's what it would look like. Again, as we go down each row, we are putting another 2 in the denominator because we are dividing by 2. And similarly, our simplified version is getting divided by 2 as well. So we see that 2 to the power of negative 4 is actually equal to 1 over 2 to the positive 4, which is 1/16. 2 to the negative 3 is equal to 1 over 2 to the positive 3, which is equal to 1/8. So that gives us two new exponent rules. We saw that 2 to the power of 0 is equal to 1, and we can generalize that any base b to the power of 0 is equal to 1, as long as that base is not 0. And in fact, that's a restriction on a number of exponent rules, which we haven't explicitly stated, but we'll state that here. Also, any base to the power of a negative number, so b to the power of negative n, is the same as the reciprocal of that base to the positive exponent. So whereas we saw 2 to the power of negative 3 could be written as 1 over 2 to the positive 3, we can also make that general statement here. So the negative in the exponent means reciprocate, means flip the base upside down and change the base to positive. So it's important to note that the negative sign in the exponent does not mean change the sign of the answer. Just because the exponent is negative does not mean the answer is going to be negative. The negative doesn't have the same meaning as it usually does in the base. It doesn't mean negative, it means reciprocate. Let's do a few examples. So we said that anything to the power of 0, except for a base of 0, anything to the power of 0 is equal to 1. So 5 to the power of 0 is 1. Similarly here, we don't need to simplify everything inside because we know that if this whole base is put to the power of 0, it's also going to be equal to 1, so we can save ourselves that trouble. We also said that if you have a negative exponent, you can change that into a positive exponent by reciprocating the base. So 1/3 to the positive 2, which is equal to 1 over 3 squared, which is equal to 1/9. So 3 to the power of negative 2 is equal to 1 over 3 squared, or 1/9. One more example, if we have 3/4 to the negative 2, again, we take 1 over 3/4 and change the 2 to positive. Remember, dividing by a fraction, you flip the fraction after the division sign and multiply, so that becomes 4/3 all squared. Notice that again, if we skip this middle step, we can go from here to here by flipping the base and then changing the sign to positive. We know that that's equal to 4 squared over 3 squared, which is equal to 16 over 9. So the same rules apply when you're working with fractions. Flip the base and then change the negative exponent to positive. That can be expressed like this: a over b to the negative n is equal to b over a to the all to the positive n. So those are exponent rules for 0 and negative exponents.